So last week we had our tests. So this week's video is going to be relatively short. Let's go ahead and go through what we did. We talked about solving one variable inequalities and the different ways we can represent them. So let's do this do now together. If you weren't here, go ahead and pause your the video and then see if you can do it by yourself first. So we solve inequalities the same way we want to solve regular equations, right? We want to get the x by itself. So the first thing we're going to do is minus 2 from both sides. Now we're left with 6x is greater than 12. And then to solve for x, you're going to divide by 6 on both sides. You get x is greater than 2. We can go ahead and try to put this onto our number line. The way I like to do it is we like to put that number in question in the middle. So that's going to be 2. Going to the positive side, we're going to positive infinity, and then on the left side, we're headed towards negative infinity. It also helps, I think, to write one number before and after. So the number after 2 would be 3, and the number before 2 would be 1. So you get a sense of like what's going on there. All right, if I want to graph x is greater than 2, since we do not include 2, we're going to draw an open circle, okay, at 2, and we are shading to the right. We're shading to the numbers that are going to be bigger than 2. Set builder notation. So that's another way I can represent our solution. Set builder notation requires, well, it's very simple. We're going to start off with like our little squiggly. And then we write x because we're talking about x, okay? So this is the variable that we're talking about. If you're talking about n, it would be n. If you're talking about y, it would be y. And then we draw a straight line. This line means such that. Just like sometimes you guys abbreviate when you're texting, like you write IDK for I don't know. This line means such that. And then we just write our answer. X is greater than 2. So the way we read this, again, I'll highlight it as I go, where the answer is x such that x is greater than 2. So our answer involves x, and x has to be greater than 2. And then last but not least, we have interval notation, and we'll go over this a little bit more in depth. Interval notation requires using the use of parentheses and brackets. So you'll see that in interval notation, we start off with 2. And then we're highlighting all the way to infinity. Okay, and we're going to close these with parentheses. We'll talk about when you're going to use brackets in just a second. So if you take a look at this chart, we have all the different methods, right? The one that we're used to is probably what's in the middle. So our symbols. And it's nicely color-coded for us. So less than is orange. And if you take a look at our number line, that's what it looks like. And we have open circle, okay? Open circle if it's less than. And same thing if it's greater than. Greater than also gets open circles. And just take a note at how it's shading. But both of these get open circles. If it's the symbol is less than or greater than, we get open circles. The other thing less than or greater than gets is parentheses. Okay, so you can kind of split it like this. And then we have our less than or equal to symbol. And the only difference between that and the less than symbol is that the number that you're at gets a closed circle. So I want you guys to pay really, really close attention. Let me show you. Right? At 3, when it was less than, we had an open circle. But if it was less than or equal to, the circle was shaded in. That means 3 is included in your solution set. Let's take a look at our greater than or equal to. So same concept as just a greater than. We get closed circles. All right, and then they get brackets. So let's do an example where we're going to get a bracket. I did mess up here. If you would like to fix that in your packet, parentheses always gets a, infinity always gets a parentheses because you cannot give me an exact number for infinity, right? It's an abstract idea. If I tell you what is infinity, you can't say it's 100. You can't say it's 1,000. It's not really a number. It's a concept. It means it goes on forever. All right, Let's go ahead and try to solve this, the example 1. So go ahead and pause the video if you need to. I want you to try this by yourself, and we'll have the examples above just so you can refer to it. So same as before, first thing we're going to do is we're going to get rid of this plus 3 by subtracting 3 on both sides. And now we're left with 6x is less than or equal to negative 30. To solve for x, we're going to divide by 6 on both sides. And we get x is less than or equal to negative 5. If you didn't get this far, go ahead and pause the video and see if you can do the number line right now. When you're ready, go ahead and unpause the video. So we have our number line. Again, we're going to put negative 5 in the middle. I'm going to label positive infinity and negative infinity, and then let's try to think of two numbers that negative 5 is between. Remember, when we're dealing with negative numbers, it's reversed, right? So on the left side of negative 5, we're going to have negative 6, and on the right side, we're going to have negative 4. I'm going to put a circle at negative 5, and we are shading to the left, right? Because we want less than. These are the numbers that are going to be less than negative 5, towards negative infinity. The other thing we must remember to do is to shade in that circle because this was less than or equal to, so we can include negative 5 in our answer. Alrighty, if you're ready, go ahead and try the set builder notation. Refer to the example above. So set builder notation, I think if we have our notes, is very simple. We have our squiggly, and it's x. This line, remember, is such that x is less than or equal to negative 5. And then last but not least, go ahead and see if you guys can do interval notation before we go over it. So in class, a lot of us were confused because we would write like negative 5, comma, negative infinity. That doesn't make sense, right? Because whenever we read, we always read from left to right. So just keep in mind negative infinity comes first, and then we go towards negative 5. Remember, infinity symbols always get parentheses. And then negative 5, since we are including it, is going to get a bracket. Alrighty. We did go over an inequality rule. So I'm on the next page now. Remember, the inequality rule is when you multiply or divide by a negative number, you must flip the inequality symbol. So I'll show you what I mean in this next example. Let's go ahead and try to solve this problem. The first thing we're going to do is, again, we're trying to get that 1 away from the x first. We're going to minus 1 from both sides. We get negative 2x is greater than or equal to positive 4. And then we're going to divide by negative 2 on both sides. So I get x here, and I get negative 2 here. Since we divided by a negative number, your inequality symbol must flip, okay? Again, this is only when we multiply or divide by a negative number. So our final answer is x is less than or equal to negative 2. Very quickly, I'm going to do this on the number line. Please pause the video so you can try it by yourself first. Otherwise, I'm going to keep moving forward. We're going to put negative 2 in the middle. Let's label negative infinity and positive infinity. To the left side of negative 2, we'll have negative 3. To the right side, we'll have negative 1. Since this is less than or equal to, that means we're going to have a closed circle at negative 2. And we're going to be shading to the left because I want numbers that are less than. So we're headed towards negative infinity. Set builder notation. Draw your little brackets or your little squiggly. We have x. Remember what this line means, this bar. Such that x is less than or equal to negative 2, and then close it off. And then in interval notation. So again, we're starting from negative infinity, and we're going to go all the way up to negative 2. Infinities always get parentheses, and negative 2, since that's a closed circle, we are including it, that's going to get a bracket. So that was one inequality, we're now going to go ahead and try some compound inequalities, which is having two inequalities at once. Okay, so let's take a look at example 1 and try to graph this. X is greater than -7 and x is less than or equal to 10. So let me do this one in red. X is greater than -7, so let's try to graph that. That means we have an open circle at -7, and I want the numbers that are greater than that. So that's shading this way. And then I also want x is less than or equal to 10. So I have another one. X is less than or equal to 10. We have a closed circle at 10. And if I want less than, we're going to be shading this way. The solution to this inequality is going to be only where the overlap is. So you see where on this left side there's only purple, right? That's not an overlap. That's not part of our solution. We need to get rid of it. So undo, undo, undo. Okay? And then on the right side where there's only red, we also need to erase that. And then our circles are going to be where we stop. So a really good way of doing this is just to, anytime we see the and symbol, we're highlighting between them. So let's try this next one using that strategy. Let's take a look at number 1. So an open circle at -5, because -5 has that less than symbol, right? There is no or equal to. And then let me do this one in green. X is less than or equal to 7. So closed circle at 7. And then we highlight in between them. It's not always going to be highlighting in between. We'll look at examples next where we don't highlight in between. Interval notation for this one. So we're going from -5, comma, 7. And now let's do the symbols. -5 is an open circle, so that's going to get parentheses. And then 7 is a closed circle, so that's going to get a bracket. Again, parentheses are open circle, brackets are closed circles. Let's go ahead and try this next one. So I'm going to do the same thing. Pause the video if you want to try this by yourself first. Otherwise, let's get started. So I have x is less than 8. I'm going to draw a circle at 8. Open circle because it's not included. And then x is greater than or equal to 2. We can draw a closed circle at 2 since 2 is included in our solution set. And then we just highlight in between them. Make sure you don't cover that 8, right? Because 8 is not part of the solution. So when I'm highlighting, what you don't want to do is go like this and go over it. Go up to the 8. All right, I'm going to do one problem where we try to solve. Notice how x is not by itself. We need to get x by itself. What we're going to do is -2 from all 3 sides. It's a double inequality, so we need to make sure we do that. We get -7 less than or equal to x less than 7 minus 2 is 5. And now go ahead and try to graph this. And we'll do the interval notation also. I forgot to do it for 3. All right, let's do this part first. So that is a closed circle at -7 since it has the or equal to. And then it's going to have an open circle at 5, right? Because it does not have the or equal to. Our solution set is going to be what's between them. All right, let's go ahead and try to write our interval notation. So we're going from -7 to +5. So this time we don't have infinity, right? Because we're not shading all the way past the number line. -7 gets a closed circle, so that is a bracket. And then 5 gets an open circle because, 5 gets a parentheses because that is an open circle. All right, the other type of problem, right? So these were and problems where we had to shade between them. And now let's take a look at some or problems. And or problems, if you might have guessed, we're going to be shading away. So let's do this first one. X is less than -7. So -7. Open circle. And less than that is towards -infinity, right? So that's what this one's going to look like. And then we shade this one. Or x is greater than 10. So an open circle at 10. And then we're shading this way. Right? Concept is pretty okay. Let's go ahead and try number 1 before we do interval notation, just so we get the hang of it. Again, it's an or statement, so we should be shading away from each other. So x is less than -8. I'm going to have an open circle at -8, and we are shading less than, so we're shading towards the left side. Or x is greater than or equal to 7. So that's a closed circle at 7 because we have that or equal to. And if I want greater than, we are shading to the right. All right, I'll do interval notation for the example, and then you can see if you can try to do the other one. We're going to write the two intervals separately. So the one in gray, right, we go from -infinity to -7. Just like we did not even like 5 minutes ago in the first lesson. Infinity always gets a parentheses. -7, since it's an open circle, gets a parentheses as well. Between the two, let me do the green one first. Leave a little bit of space. So the green one is going to go from 10 to infinity. 10 is an open circle, so that is a parentheses. Infinity is always parentheses. And then between the two, to write or in math language, we write a U. All right, let's see if we can do this next one. Go ahead and write the purple one first in interval notation. So the purple one would be, we go from -infinity to -8. Remember, infinity always gets parentheses. -8 is an open circle, so that gets a parentheses as well. Let's go ahead and try the green one now. The green one goes from 7 to +infinity. Infinity, again, always gets a parentheses. 7 is a closed circle, which means that's going to get a bracket. Put a U between them, and we're good. All right, and then, there's some extra practice problems. I want to do number 3. That one looks fun. So when we do like this on or statements, unlike the and statement where it's just one like jumbled together, you see how it looks like it's one piece, right? It's all stuck together. When you're doing or statements, it's going to be 2 separate pieces, so we're going to treat them as such, okay? So I'm going to rewrite it. -4x is greater than or equal to 40, and then 8 plus x is greater than 4. So let me do the left side. The left side, we're going to divide by -4 on both sides. So I'm going to get x here. 40 divided by -4 is -10. Since we divided by a negative number, what do we have to do? We must flip the inequality symbol. So this inequality now becomes less than or equal to -10. All right, on our right side, we're going to subtract 8 from both sides, and we get x is greater than -4. Let's go ahead and graph these. I'm going to graph the purple one first. Less than or equal to -10. I have a circle at -10, and it is a closed circle. Less than means we are shading to the left, towards -infinity. Let's go ahead and do the right one. X is greater than -4, so I have a circle at -4. It is open, right, because there is no or equal to, and then we're going to be shading to the right because I want the numbers that are bigger than -4. Go ahead and pause this. See if you can do this in interval notation. Do it piece by piece. Do the purple piece first, and then the green piece. All right, so the purple piece, we go from -infinity to -10. -infinity, remember, always gets parentheses because it's an infinity symbol. -10 is a closed circle, so that's going to get a bracket. Let's put a U there. And then let's do the green piece. Green goes from -4 to +infinity. I'm going to do the easy piece first again. Infinity gets a parentheses. And then -4, since it's an open circle, also gets a parentheses. So there are more practice problems for you guys to try. Please, please, please try them. Okay, we are in our second marking period now. I appreciate those of you guys who are watching this video. I really, really do. And then if you guys need anything, again, you know, you can reach me on Remind. You can email me. You can ask me in class. You can find me outside of class, whatever I can do to help you. Alright, thank you for watching this video, and I will see you in class. Bye!